comparing and ordering rational numbers. This lesson applies what you learned in the last lesson about translating between fractions and decimals. To be able to compare or order rational numbers, you want to translate those numbers to the same language. Think about if I were talking to you and I just randomly threw in some Spanish words. It would be very hard to follow, and math is no different. You want to speak the same language. So if we're speaking in fraction, we want to make everything in fraction. Or if we're speaking in decimal, we want to turn everything into a decimal. And you know how to do that from yesterday. If it's going from a decimal to a fraction, you say that number out loud, and then you simplify it. I'm sorry, let me back up. You say that number out loud, you put the decimal on top of the place value that you found by saying it out loud, and then you simplify. Or if you're turning a fraction into a decimal, you divide the top number by the bottom number. Rational number, that was a word that I just used that you might be thinking, ooh, don't know what that means. Well, it's really just a number that can be written as a fraction. It's a number that makes sense. If I ask you to think rationally, I'm wanting you to think in a manner that makes sense. So this is pretty much just a positive or negative whole number, a decimal, or a fraction. This whole unit over number system is dealing with rational numbers, being able to add, subtract, multiply, and divide positive or negative whole numbers, decimals, and fractions. Some examples of an irrational number are pi, because it is a decimal that goes on and on and on, and it doesn't repeat or terminate, and so there's no way to write it as a fraction. Or something like the square root of a negative 25, and you'll learn in 8th grade why that is an irrational number. Some examples: 4 3/5, 0.7 repeating, negative 0.1, and the whole number 41. Those are some examples of rational numbers. So let's practice first by comparing. When you see this box right here, they're wanting an inequality symbol: greater than, less than, equal to. So 3 4/5 and 3 2/3. Yes, those are both already in fraction language, but it's kind of hard to decipher which one is larger because they have different denominators. So I would suggest putting it into a decimal. I think decimals are easier to deal with in general, and especially when you're comparing them. So let's turn those into a decimal. I know these offhand, and I hope that eventually you will too. If not, you could divide this out, and you would get 3.8. And then 3 2/3 is 3.6 repeating. Now I can tell by looking at this that the 8 is bigger than the 6. But if that happened to have been a 6 there and this 6 was repeating, sometimes it's helpful to lengthen that out and write out a bunch of 6s to make it easier to compare. Now, do you see why I told you last lesson that you want these memorized? I didn't have to do that long division because I have those values memorized. 3.8 is larger, so I'm going to put that it is greater than. Let's come over here to practice B. Negative 0.6 and negative 2/3. We have to kind of think about negatives and picture these numbers on a number line. Like I said, I think it's easier to deal with decimals, so I'm going to choose to turn negative 2/3 into a decimal. That's the same fraction we have over here, so its value is negative 0.6 repeating. I'm going to go ahead and write this one down here just so it's on the same line. It still seems kind of tricky when you are comparing those. This is like what I was talking about over here. What I would do is actually lengthen those 6s out. And I'm going to take that bar off since I've lengthened it out. Now when you go to compare these, you have to remember that on a number line, the greater the absolute value, the farther to the left it's going to be. So relate this to money. Would you rather have 60 cents, 0.6 in debt? Would you rather owe your parents that? Or would you rather owe them 66 cents in debt to them? Do you kind of see how that works? The 0.6 is greater because 0.6 repeating is going farther into the negatives. There's not a big difference between these numbers, but there is still a difference. So negative 0.6 is greater than negative 0.6 repeating. Okay. Let's practice with these. Order these from least to greatest. I want you to try this one on your own, pause the video, and then restart the video to compare with me. Okay, the first thing that I did was I translated this fraction into a decimal. Put the top number in the box, the bottom number on the outside, divided it out, I got 2.1. Now I need to compare these three numbers to put them in order from least to greatest. You should have picked out that the negative is the least one. Without even having to do any translating, since it's the only negative, I know it's going to go first because it is the least value. So really, I'm just comparing this one and this one. I'm going to change that a little bit. Okay, so when I compare those, 0.05 is less than 0.1, so the 2.05 comes down, and then you want to write your answer in the form that it was given. Now, you probably looked at it like I did and said, oh wait, I must have messed up, but it was already in order when it was given to you, so don't always assume that you're going to have to change something. So there is my final answer.